Absolute value equations. So a reminder, first of all, definition of absolute value is defined as, when we think about absolute value, we think of what? Okay, always positive. And I think of it as distance, number is from 0. Okay? And distance always has to be positive. Okay? Because if I look at my distance from me to Ridge, okay, that's a positive distance. And it doesn't matter, even if I turn around and facing the other way, the distance from me to Ridge is still a positive distance. Okay? Can't be negative. Right? It's kind of like on your car. Right? You put it in reverse, it starts backing up. Does the odometers go? Do you reduce your odometer then? No. Okay. You can't get on the highway, go backwards to turn the odometer backwards. Okay. So, all right. Now, with this definition, if C is greater than or equal to 0, then the absolute value of C is C. If C is, and this is important, if C is less than 0, in other words, it's a negative number, then the absolute value of C is the opposite of C. Okay? So think about that for a second. If C is a negative number, then the absolute value of it is the opposite of that, right? Okay. Now, this is important because when we look at this part right here, it says, for example, because 5 is positive, the absolute value of 5 is 5. Because negative 3 is negative, the absolute value of negative 3 is the opposite of negative 3, or 3. But then we bring in some symbols and some other things, and it changes stuff a little bit. Think about pi minus 6. Is that a positive or negative number? It's negative, right? Because pi is 3.14 approximately. And if we do 3.14 minus 6, we're going to get a negative number. So then, how do I find the absolute value of that? Okay. And the thing is, to find the absolute value of that, then, we're basically just going to change the signs. So the absolute value of pi minus 6 is 6 minus pi. All right? Just want to make sure you understand it. Its absolute value would be 6. Yes. Yep. The absolute value of pi minus 6 is 6 minus pi. Okay. All right. So your answers then here. Solutions here for number 1 would be negative 2 and 8. Right? So a reminder then, when I solve absolute value equations, we have to set it equal to the positive number. So x minus 3 equals 5, or x minus 3 would equal negative 5. You have to take the fact into account that what's inside the absolute value could be a positive or a negative number, and it would still be a true statement. And then it's a matter of solving those equations. Add 3, we get 8. Subtract 3, or add 3 there, we get negative 2. There we go. Okay. Number 2. Okay. Now, one of the things we have to pay attention to here is the fact that sometimes there's extraneous solutions. All right? Now, without reading that, who knows what an extraneous solution is? Who remembers an extraneous solution? We've talked about this before. Not this semester, but before. Okay. Nobody? All right. Garrett says they're fake solutions. Kind of, but not really. All right? An extraneous solution or root is one that shows up in your answer, but when I check my answer, it doesn't work. Okay? Now, the instance would be when, for instance, you would have the square root, or the square root of a negative, or x squared is going to equal a negative number, because x squared can never equal a negative number, or the absolute value is going to equal a negative number. Absolute value can never be negative. So let's take a look at this problem here. All right? So first of all, I'll just go ahead and show you the solution. All right? So you should get 4/3 is a solution to this. Right? And I'm going to go through and show you why. So if you got negative 2/5, that's extraneous and doesn't work. But notice the graph. So look at this graph. Oops, come on. There we go. Notice when I graph the absolute value of x plus 3, right, we get this graph here. All right, that nice V. When I look at the graph of 4x minus 1, I get this nice line here. How many places do they intersect? Only one. So how many solutions can there be? Only one. Okay, so let's verify that and see why. So we take x plus 3 and we set it equal to 4x minus 1. Or x plus 3 would equal the opposite of 4x minus 1. So negative quantity 4x minus 1. So we solve these. Right? Subtract x. We get 3 equals 3x minus 1. Add 1. 3x equals 4. And divide by 3. Right? So we got 4/3 is one of our answers. Okay? And they said that one worked. Let's try the other side. We get x plus 3 equals negative 4x plus 1. So we're going to add 4 to both sides, or 4x, and subtract 3. So we get 5x equals negative 2. Divide by 5. We get x equals negative 2/5. Now, to check it, that means we put the number back in for x, right? Okay. Well, basically, your check for these only really needs to be that is it going to be a true statement? In other words, if this is absolute value here, that means then that the right side of the equal sign must always be positive. If what's on the right side of the equal sign then is negative, it can't happen because the absolute value, the graph of the absolute value, which we see here, is only positive numbers or 0. And so if I'm ever going to end up with a negative, it won't work. Yes, sir. As far as here? No, it doesn't. Okay. All right, her question is, could I do negative of x plus 3 and equals 4x minus 1? And I know that's what they do in the book, but it doesn't matter which side it is. Okay. Right. Now, so if we look at these two, 4/3. If I put 4/3 in for x, 4 times 4/3, is that a positive number or a negative number? Positive. Okay. Is it bigger than 1? 4 times 4/3. All right, let me actually do it. Go down. Right. So we have absolute value of 4/3 plus 3 equals 4 times 4/3 minus 1. So this is 4 and 1/3, right? The left side. 3 plus 1 and 1/3 is 4 and 1/3. This equals, what's 4 times 4/3? 4 times 4, 16 over 3, right? And 16 over 3 minus 1 is 13 over 3, right? Because I'm subtracting 3. Okay. Now, is the absolute value, well, let's see, 4 and 1/3, is that the same as 13 over 3? Yes, it is. Okay, that checks. Works. Okay. Now the other side. Okay. So we have the absolute value of negative 2/5 plus 3 equals 4 times negative 2/5 minus 1. So let's look at the right side for a moment. Okay. 4 times negative 2/3, that's negative 8/3, right? And if I subtract 1 from that, I still have a negative number. Is the left side here ever going to be negative? The absolute value of a number is always positive, so this cannot be true. So that means then that this cannot be a solution. So it's called extraneous. It's a solution that I got, but it doesn't work when I check it. So my answer here is just 4/3. All right, for number 3, there are 4 solutions here for number 3. Negative 3 or negative 1 plus or minus the square root of 15 over 3, 0, and negative 2. Did you get all 4 of them? Okay. Now, reminder, we do this the same way. 3x squared plus 6x minus 1 equals 1. Or 3x squared plus 6x minus 1 equals negative 1. Now, to answer Allie's question, doesn't matter which one. In this case, it's much easier to make the 1 negative for the right-hand side than to do the left side, to change the sign. Does it matter? No, it doesn't, because multiplying either side by negative 1 just still is the same thing. Okay? But think about it. This is what kind of an equation? Quadratic equation. In a quadratic equation, you can have 0, 1, or 2 different solutions. Okay? So that means we could have up to 4 solutions for this problem. So you have to do both of these parts like you would any other quadratic equation. Hopefully it's something I can factor. If it's not, then I either have to complete the square or use the quadratic formula. Okay. So let's see. If we subtract 1 here, we have 3x squared plus 6x minus 2 equals 0. Okay? So this one, hopefully I can factor it, but I don't think so. The other side, if I add 1, we get 3x squared plus 6x equals 0. Okay, that's nice. This side here, I can just factor that, get my zeros easily, 0 and 2, or 0 and negative 2. This side here is not factorable, so probably going to use the quadratic formula then to find the answer. Okay. All right, does that make sense? Then we went through number 4. Okay. Now here's a radical equation. We can still have extraneous, right? Because what can you not take the square root of? A negative number. Or if I take the square root, I can't get a negative number. Okay? Now this isn't solving an equation by taking the square root of both sides. This is an equation that has a square root in it. So my result cannot be negative. Okay? If my result is negative, once again, you have an extraneous solution. Okay? Who wants me to do this one? Anybody? All right. Okay, so to do this one, the first thing you have to do is get the radical by itself. You have to isolate the radical. So we have to subtract 5. So we get the square root of 3x minus 11 equals x minus 5. Now remember me telling you about how important it was to know the perfect square trinomials? Okay, remember that? Here's a perfect example. Because if you don't know it, you're going to have to FOIL, and it takes a lot of work to get there. I mean, not a lot, but a little bit of extra work to get there. But if you do understand perfect square trinomials, you'll just be able to write it down. Okay? because now I'm going to square both sides. So we have 3x minus 11 equals, and here's where that perfect square trinomial is. X squared minus 10x plus 25. The last term is the second term squared. The middle term, you double it. Okay? A plus b squared equals, oh, that's not what I want to use. X plus a squared is x squared plus 2ax plus a squared. Okay? So all that does, this number is doubled for the middle. Okay? Okay. So we have a quadratic equation, which means we want it to be equal to 0. So we're going to subtract 3x and add 11 to both sides. All right, and then hopefully I get something I can factor. But sure I can. What are the factors of 36 that add up to 13? Oh, this was example in the book. It wasn't even the one you did, was it? Sorry. All right. So this is x minus 9 and x minus 4. So x equals 9 or 4, excuse me. Okay. Now, let's see if they work. So let's think about it for a second, all right? I want you to use your head. If I put 9 in here, okay, can I take 5 plus some number and get 9? Right, because this is going to be a positive number here, right? 5 plus 4 would be 9, okay? Now let's think about if we put 4 in for x. Can I do 5 plus some number and get 4? Because this square root has to be positive, doesn't it? So from the 5, it can only get bigger. Since it can only get bigger, that means then that 4 is an extraneous solution, and the only answer I would have would be 9 then. Okay? So with radicals, it makes a difference also. And the same thing here with number 4. For yours, negative 2. If you did that, negative 2 would be extraneous, so the only answer there would have been 4. Okay? But once again, you would have to subtract 1 from both sides, square it, okay, and so on. Now when you square this one, when you square the 2x minus 1 in this case, not quite as easy as of a perfect square trinomial, but you just have to think about the fact that I'm going to get 4x squared here. If I multiply these together, it doubles, so negative 4x plus 1. Quadratic equation, get equal to 0. And if negative 2 and 4 were the numbers I got, it would have been factorable once again.